Okay, so what we're going to be doing now is going through the Chapter 7 final exam review problems. So first off, what we have are some inverse problems. When we have inverse problems, remember that the very first thing we have to do is switch the variables. So all we have to do is switch the x and the y. So from y equals e to the 7x, it becomes x equals e to the 7y. That's it. And now what we have to do is we have to solve for y. Given that this is an exponential equation, I have to make this a logarithm. So what we can actually do is just rewrite this. So remember, if I have that y is equal to b to the x power, this is the same as saying x is equal to log base b of y. Well, here the base of the exponential function, so this base of the exponent, is e. So we're going to have log base e. But I don't write log base e, I write ln for natural log. And this is going to be the natural log of x is equal to 7y. If you're confused with this, I recommend you go over these formulas, you go back and forth. All it is matching. So this is the exponential part, and then this is on the other side the equal sign, this x. Over here, b to the x, that's the exponential part. So this is the other side of the equal sign. So it's just placing these in different spots. That's it. And now to get the y by itself, I'm going to multiply both sides by 1/7. Oops. And I'm going to make sure that I don't multiply that x by 1/7. So I get that y is equal to 1/7 natural log of x. Now just keep in mind that this is the inverse, so I'm going to put that -1. And so that's my answer. I'm going to put it in a box. All right, moving on to the second one. Same deal. Finding an inverse, we're going to switch the variables. So I do x is equal to log base 7 of 3y plus 2. And again, it's just a rewriting of these forms. So here it's a logarithmic form. So I'm going to change it to an exponential, and this will free up my y. So I'm going to have 7 to the x power is equal to 3y plus 2. To solve for y, I have to subtract 2 from both sides, so I get 7x is equal to 3y. Oops, 7x minus 2, sorry. I'll erase that. 7x minus 2 is equal to 3y. And then I'm going to divide everything by 3. Keep in mind, I divide everything. So I can write this as 7 to the x minus 2 over 3 is equal to the inverse of y. All right, down here, this is a logarithm. Now again, because it's ln, this natural log, that means that the base is e. However, before I can turn this into an exponential, I have this 2 here. So I have to get rid of the 2. So after I change my variables, I'm going to divide both sides by 2. So I get x over 2 is equal to the natural log of y. And again, to put this in an exponential, I'm going to have e, because that's the base of the natural log, to the x over 2 power is equal to the inverse of y. And done. Number 4. So what should I do first? Quick answer, switch the variables. X is equal to 4 plus e to the y power. We need to isolate that y, but I can't take the logs of this equation until I get rid of this 4. So I get x minus 4 is equal to e to the y power. Now I'm going to rewrite this as natural log of the whole thing, this whole block, x minus 4 is equal to the exponent. So in this case it's y. So I solve for y, and there's my inverse. Inverses, I know we're giving a lot of people issues in class. Just remember, switch the variables, solve for y, isolate the y, and in these cases all we have to do is rewrite them. So definitely go over those formulas and know those for the exam. Compound interest problems, I think everybody's feeling okay with. So there are 2 formulas that we have. So whenever we have compound interest, that is a certain amount of compoundings per year, we do that the account is equal to principal times 1 plus rate over n for number of compoundings to the n times t power. T stands for years. In this case, it's 3 years. Continuously, that's going to be the A equals principal times e to the RT. Because continuously means an infinite amount of compoundings, so n can't be anything for formula, so there is no n as formula. But everything else stays the same, so we get A is equal to 3,000 times 1 plus, if this is 2.7% annual interest, I'm going to have 0.027. Remember, we put this in decimal, so we divide this by 100. Number of compoundings here, quarterly, so there are 4 quarters in a year. 4 to the 4 times 3 power. And now when we put this into the calculator, which I know that you cannot see right now, we just have to be very, very careful with the order of operations. You should be using the Inspire if you're doing this for my class. So it's very easy to see what you put in with the Inspire. But after we put this in, we get 3252.23. Remember, this is money, so we should put that $sign in the answer. Here, A is equal to 3,000. E to the, again, 0.027 times t power. With this, remember, just keep E as E. There is absolutely no need to change that into the true value of E, because remember, it's an irrational number, so it's nothing. Don't round that. Just keep it as E in the calculator. All right, so A is equal to, in this case, 3253.11. These two values should be something similar. So in this case, they're only off by less than $1. So bear that in mind. If you get something such as 9,000 for one of them, just remember that and think that there's probably something wrong. All right, so that was page 1. Now we can go into page 2 and begin with these. So with the condensing problems, remember that what you have to do are the 3 properties. These are in your 7.5 notes. So the 3 properties are the power property, the product property, the quotient property. Very, very similar to exponential properties, or properties of exponents. When we are condensing, the very first property that we use is power. Always, 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 always. So power property says that this coefficient becomes the exponent of what we're taking the log of. So in this case, we're taking the log of 2x, so the 5 drops up there. And in this case, we're taking the natural log of x, so we get that. So now, 2 to the 5th is 32, x to the 5th is x to the 5th. And now I'm presented with this, which is a clear indication that I'm going to be using my product property. So this becomes 1 natural log of 32 x to the 8th. Here I have 3 terms. So it looks like I'm going to be using the product property and the quotient property, but before I do any of that, I should always use my power property first. So I get log of 5x plus log of 3x squared minus log of 2x to the 4th. We're going to simplify this real quick. So I get the log of 5x plus the log of 3 squared is 9x squared minus the log of 2 to the 4th, which is 16x to the 4th. Now when I add these together, remember I can write that as the product, so it's going to be the log of 5 times 4, which is, oh sorry, this is 9. Can't read my own handwriting. 5 times 9, which is 45, x to the 3rd. And I'm not going to touch this log 16 x to the 4th, only because I'm going to take each property as time. I can do this all in one clump, but it can easily be confusing. So I'm going to change this now with the quotient property. So I write it as 1 log of 45 x to the 3rd over 16 x to the 4th, but those x's cancel out. So I get log of 45 over 16x. And that's it after simplifying. So, not bad. Remember, go over those three properties, and they also come in handy when you're solving equations such as this. Here I have a logarithm, so I know I need to rewrite this as an exponential. However, I cannot rewrite it as an exponential until I combine these logs. So I do that using the the product property, both begin with a P. X times 4x is going to be 4x squared equals 4. Now I can rewrite this as an exponential. So my base is 2, the other side is 4, so I get 2 to the 4th is equal to 4x squared. That's 16 equals 4x squared. 4 is equal to x squared, so x is equal to 2. Now the square root of 4 is in fact plus or minus 2, but if you look, if I have x being negative 2, I'm taking the log of a negative number, which I can't do. It doesn't exist. So only answer is x equals 2. If you have x equals negative 2, it is extraneous, so make sure you have that. Okay, now we have this e to the 4x. Again, we need to get rid of everything else. So I'm going to start by subtracting 3 from both sides. So I get 2 over 7 e to the 4x is equal to 4. Multiply both sides by the 7 halves. And now I get e to the 4x is equal to, well, here the 4 over 2 becomes 2, times 7 is 14. Now I have natural log of 14 is equal to 4x. Whenever we are presented with a log or a natural log or anything that we have to compute like this, it's best to put this into a decimal as soon as we get it. So here I'm going to put this as 2.639 is equal to 4x. And when I divide that by 4, I get that x is equal to 0. We can round that to 660. Again, I'm doing this with a calculator, so make sure you have your calculator handy because on the final exam we're going to need to see decimals. Here, this is pretty straightforward as what we have to do. We have to rewrite this as a logarithm. So the 5, that's the base of the exponent, so it's going to be the base of the log, and I'm going to take that of 24 and set that equal to the other side. Now here your calculators can only do log base 10. So I'm going to change this using the change of base formula. So if I take the log of 24 divided by the log of 5, that's going to give me this value of log base 5 of 24, which in this case is 1.975. And here I'm going to add 3 to both sides, divide by 2, and what I end up getting is 2.487 to equal x. And for this one, pretty similar, except the base is e. So I get e to the 3rd power is equal to 4 minus 3x. That's a 4. So e to the 3rd, that's just a little quick fix into the calculator. And that's 20.086 is equal to 4 minus 3x. So I'm going to subtract 4 from both sides, divide by negative 3, and I get that x is equal to negative 5.362. That's a 3. Now, a lot of people think that because this is negative, it's extraneous because you can't have a negative log. But if you actually look really carefully in this equation itself, you're taking the log of 4 minus 3x. So when you put this back in, you actually do end up getting a positive number you're taking a log of. So there's nothing to worry about there. So just be careful when you're looking for extraneous solutions. All right, and we have one more page to go. 4 questions, not bad. So we do have another condensing problem. This one got lost and separated from the others. So we will take a look at that right now. And we have another try. So again, very first property that we do is the power property. And this becomes 3x squared. So I get the log of 4 plus the log of x to the 3rd minus the log of 9x squared. Going to use the product property here. So the log of 4x to the third minus log of 9x squared. Because this is subtraction, I am in fact going to be using the quotient property. So this becomes 4x over 9, and that's after simplifying. I put these parentheses in there so it's clear that I'm taking the log of this whole fraction. It avoids any confusion, and I recommend you do it on your test. Here, exponential. So I change this to a logarithm. The base is 6, so this becomes log base 6 of 39 is equal to 3x. Well, if I put into my calculator log base 6 of 39, again, it can't do it, so I have to change this to log of 39 over log of 6 is equal to 3x, blah, blah, blah. And this does, in fact, give me 2.045 is equal to 3x. Divide that by 3 to get that x is equal to 0.682. All right, here, evaluate. This is just practicing using the change of base formula. So log of 45 over log of 9. Please note, this does not equal log of 5. I cannot divide the 45 and the 9. That does not work. I have to actually put this into my calculator and get this answer. So if I do this, I actually get 1.732. There. All right, and the final problem here, 16. All we have to do is solve. So we do have an exponential. This is very, very, very similar to one we had earlier. And in this case, I'm going to add 10 to both sides, so I get 4/7. E to the 5x is equal to 4. Multiply both sides by 7/4, which is really nice because these 4's cancel out. So I get e to the 5x is equal to 7. Well, now, again, because this is e, that means that I will be taking the natural log of both sides. So I get that 5x is equal to the natural log of 7. Natural log of 7 is actually 1.946. And if that's 5x, I can divide that by 5 to get that x is equal to 0.389. So those are the solutions for the problem. This whole sheet will be up on the Moodle for you to check out in PDF form. I highly recommend you go through these answers and definitely try these again before the final exam. All right, any more questions or anything, please feel free to let me know. All right, guys, best of luck studying.